A particle starts from a rest and moves in a straight line. It travels a distance 2l with uniform acceleration and then moves with a constant velocity a further distance of l. Finally comes to rest after moving a distance of 3l under uniform retardation. Then the ratio of average speed to the maximum speed of the particle. In the given question, a particle is moving along a straight line path. Initially, it starts from rest position, u is equals to 0. After traveling a distance of 2l, let the speed of the particle is v. Take these 2 points a and b. So at a point initial velocity is 0 and b point final velocity is v. So in between a to b, the body has acceleration, let it be a1. After then, the particle travels from b to c, distance in between these 2 points l. But the particle moves with constant velocity. With v velocity only, it covers from b to c. So here acceleration is equals to 0. There is no change in the velocity. It is moving with constant velocity. Again from C to D point, it travels a distance 3l with constant deceleration. Let it be A3. And finally, the particle comes to rest position. Final velocity is equals to 0. From A to B, initial velocity 0, final velocity is v and acceleration is a1. Time t1. Find out the acceleration of the particle from A to B. Take the equation v square minus u square is equals to 2as. Final velocity v. So v square, initial velocity is 0. Acceleration a1 and distance travelled by the particle is 2l. From this, a1 is equals to v square by 4l. Now here we want time taken by the particle to travel from A to B. Take the first equation. V is equals to u plus at. V is equals to initial velocity 0 and acceleration is v square by 4l. Into time is t. Take t1 here. So one v get cancelled. 1 is equals to v by 4l into t1. From this t1 is equals to 4l by v. Particle travels a distance 2l with acceleration a1 and time t1. So here acceleration is equals to v square by 4l and time is equals to 4l by v. Initially starts from rest position and at b point velocity of the particle is v. With the same velocity only, particle travels another l distance. So at this point acceleration is 0. From B to C, acceleration 0 and moving with constant velocity. The time taken by the particle to cover distance L, T2. So velocity is equals to distance by time. From this, time is equals to distance by velocity. Here distance covered by the particle is L and constant velocity is v. T2 is equals to L by v. And next from C to D. From C to D. Initial velocity is equals to v. Find out the acceleration. Take again equation v square minus u square is equals to 2as. Finally, particle comes to rest position v0 minus initial velocity is v. v square is equals to 2 into acceleration a3 into distance travelled by the particle is 3l. 3l. So minus v square is equals to 6a3l. From this, a3 is equals to minus v square by 6l. Here acceleration is negative. That means a body has the retardation. Now find out the time taken by the particle to come to rest position. Take first equation. V is equals to u plus at. Final velocity 0, initial velocity v and acceleration minus v square by 6L into time t3. V square by 6L into T3 is equals to V. Here one V get cancelled. T3 is equals to 6L by V. Now we know time taken by the particle in these three cases. Here we have to find out the average speed to the maximum speed. Throughout the journey, the speed of the particle is maximum. That is only V. So maximum speed is equals to V. Now find out the average speed. Average speed is equals to total distance by total time taken. Initial distance is 2L and after then distance L, final distance is 3L. T1 is equals to 4L by V plus T2L by V plus T3 6L by V. 2L plus L, 3L, 3L plus 3L, 6L. 6L by, here denominators same, so add the numerators. 4 plus 1, 5, 5 plus 6, 11. 11L by V. L get cancelled. That is equals to 6V by 11. This is average speed. Now we want the ratio of average speed to the maximum speed. Average speed to the maximum speed is equals to 6V by 11 by V. It becomes reciprocal V. VV get cancelled. So answer is 6 by 11. First option is correct.